Hello again. Today we're going to solve VCE exam 1, question 7. This is a complex familiar question because involved with the if inverse function. Before I do that, just remind everyone to subscribe channel just by clicking the bell, so you can show your support to this channel. So it does take a long time to build this channel to help you guys to learn mathematics. So if you can show some of your appreciation by subscribe the channel, thank you for that. All right, and we're going to start working on this question. We got a function which is x squared minus 2x, which is a parabola, but it's only half the branch. Can you see this? The function is given. However, we only domain is from negative infinity to positive 1. So which is this guy here. So this is the original function, fx. All right, so now we're going to determine what is the inverse. So we need to find we need to determine what is the f inverse. Now we put the inverse as a negative 1, not to the power negative 1. So that means the inverse. All right. So how do we do that? So let's start doing the first. We know the domain is given. So we're going to say y. We're going to put a y equal to 2x squared minus 2x, change to perfect square. Well, plus 1, take a 1, take a negative 1. So therefore, y equal to x minus 1 to the power of 2 minus 1. All right, then we move negative 1 to the other side. So we can know x minus 1 square equal to y plus 1. Now, because y originally, you can see y is greater than negative 1, because if you look at the original function, the range is greater than negative 1. So therefore, the y plus 1 should be greater than 0. So we can start doing the square root. But don't forget, put a positive and negative. So therefore, I'll move 1 to the other side, become, so x equal to 1 plus minus square root of y plus 1. Now we swap. So this is how we do it, swap. So don't forget, swap x with y. So y become x, x become y. So that's why we got an inverse. So the domain is x greater and equal to negative 1. However, we need to decide, because we got two, it's not a function because it's a relation. You got two solutions. So we know this is not a function. So we need to decide its function. So that means we have to decide whether it is a positive or negative. So if you look at the inverse function graph, can you see my red line here? So that's the red line I draw. That's the inverse. So you can see that inverse of function is below the y equal to 1. So that's y to 1. All right, so therefore, this means y has to be less than 1. So therefore, we cannot choose plus. So the plus is not applied. So that's why we need to choose the negative 1 minus, because we decided it's a function, not a relation. So we need to decide the negative side. from the graph. All right, so that's why we decided the inverse function is 1 minus the square root of x plus 1, and domain is the x belong to -1 to the positive infinity. So now we're going to do the enclosure areas on the curve. So we got 3 functions. So we got f, original function, inverse, and there's another one called y equal to -x. So we know y to -x is it's a diagonal, but from the other side. So that's the y, that's the blue line. Y green line, sorry. Y equal to -x. So we need to find that those 2 areas are shaded. Can you see the area 1 and area 2? We need to add them together. So you can see those 2 areas are almost identical. So that means we can say total area is area 1 plus area 2. So that means equal to twice of area 1. So if we can work out area 1, we times by 2. So that's why I'm going to do that. So I'm going to integrate from 0 to 1, and the area 1 equal to -x, which is on the top, minus the fx. So simplify, put a -x in the front, square x, and then negative become positive x. So we integrate it to these 2, then substitute value into the equation. So we got the answer is 1/3 units squared. So that's method number 1. So don't forget to times by 2. Second method is we say if we're going to be, because those 2 areas are identical, so we can use times by area of 2 instead of area 1. But that's a little bit harder because the function is different. So this time we start from -1 to the positive, just to 0. Then the function on the top is -x, and the function on the bottom is the inverse. So that's f1, -1. All right, so let's do the simplification. I'm going to expand in the brackets. So I'll move this guy here. You know, the square root, I'll change to the index, 1/2. So I'll put in the front. Then you have a 2 -x minus -1 become -2x plus 1. So then our inverse individually, the first one our inverse integrated to x plus 1, 3 to the power of 2. So because you can use substitution method. So this is a pretty simple substitution. So we know the substitution. So therefore, the second one is x plus 1 squared, because 2 cancel. Now we're going to substitute the values 0, -1 into it, so you will achieve the same answer. So the answer is 1/3 units squared. So that's a method 2. I don't think method 2 is better than method 1, so I prefer method 1. There's another way to do is using the area, method 3, using the triangle area. So if you look at the triangle here, we got, let's say we have a triangle here. So that triangle is half the base times by height, so which is a -1/2, and take away the area under this f, so this f from 0 to 1. So then you can achieve the same goal, integration, then you simplify, substitution, so you achieve the same results as well. So I think that the first method is probably the better. The method number 1 is the simplest method. But It's good things to know all this where we can solve one question in different methods. All right, thank you for watching. I'll see you next time. Bye.